Hello everyone. Just a minute, I'll check live is coming or not. Yes. Hello everyone. I am Balaji Rao. Welcome to BR Max class. In last class, we learned how to find points of discontinuity of a given function. In this class, what we are going to learn? You observe this question. In this question number 7, what is there? Find all points of, look here, question number 7. Find all points of discontinuity of f. Okay, this problem we will do. And you see this question, find all points of discontinuity of the given function. You can observe here, in the given function modulus of x is there. You see the 7th question, in this also, in the given function modulus of x is there. Okay, and you see this 9th question, find all points of discontinuity of f. In this also, in the given function mod x is there. Okay, so all these three problems comes under one model. So these problems are little lengthy. It takes time. Have patience and try to understand these things. Before going to start this video, please drop a like for this video and let's play the intro. That's good. Are you all ready to listen the class? Yeah, that's great. So first we'll try to understand what is the given question. You observe, find all points of discontinuity of f. We need to find where this function is discontinuous. Okay, and the function is defined like this. In last class also we done problems like this. First thing is, we need to identify what is domain of this function. Is this function is defined for all real numbers? Is this function is defined for all real numbers? For example, x equal to 0. Then which function to choose? You observe 0 is there in this interval. So when x equal to 0, we need to choose this minus 2x. Okay. When x equal to 1000, then which function to choose? 1000 is greater than 3. So I need to choose third function. Okay. X value is minus 1. X value is minus 1. Which function to choose? Minus 1 is in this interval. In between minus 3 and plus 3, minus 1 is there. So we need to choose this function. Suppose x value is minus 5. X value is minus 5. Minus 5 is less than minus 3. So in this interval, minus 5 is there. So at that time, we will choose this function. So what you understand? You understand that domain of this function is all real numbers. This function is defined on all real numbers. Okay. So we need to check discontinuity. We need to check where the function is continuous, discontinuous. I need to check the continuity. I need to check the continuity of this function on real numbers. Okay. And here if you observe, this function varies at 2 points. One is at minus 3, another one is at 3. You observe, when x is less than minus 3, this is the function. When x is in this interval, then this is the function. When x is in this interval, then this is the function we need to choose. So what I'll do here, I'll divide this problem into these cases. First one, minus 3. I'll write here, I'll mark minus 3. Okay, first one, I'll write minus 3. Next one, you see here, 3. Minus 3, 3. Only two numbers are there. So I'll mark those two numbers. Minus 3, 3. Okay. Now I'll check the continuity of the function in this zone. I'll take it as case 1. I'll check continuity of this function whenever this x value is less than minus 3. I'll check where is there any point of discontinuity is there or not. Okay. Later, case 2. I'll check continuity of the function at x equal to minus 3. I am taking it as case 2. Okay, next case 3. I'll check continuity of the function in between minus 3 and plus 3. I'll take it as case 3. I'll check the continuity of the function in this interval. Okay, now case 4. 1 minute, let me check the comments. Hello Rahul. Yeah, good evening, good evening. Okay, right. Uh, Case 3. What is case 3? I'll check the continuity of the function at this point at x equal to 3. Okay. I'll take that as case 4. What is case 4? Checking the continuity of the function at x equal to 3. Checking the continuity of the function at x equal to 3 is case 4. Now, case 5. When x value is greater than 3, then I'll check the continuity. So, what they are asking in the question, find all points of discontinuity of the function. To find all points of discontinuity of the function, from the given function, I checked what is the domain of the function. This function f of x is defined for all real numbers, but this function varies at 2 points, at minus 3 plus 3. So, I divided this problem into 5 cases. In case 1, I'll check in this zone any point of discontinuity is there or it is continuous everywhere in this zone. Next, in case 2, in this area, any point of discontinuity is there or not, I'll check. Next, in case 3, I'll check in this zone, any point of discontinuity is there or not. Case 4, I'll check at this point of continuity, point of discontinuity or point of continuity, I'll check. Okay. Next, case 5, I'll check in this zone, is this function is continuous or discontinuous. I hope you understand, right? Okay. So total 5 cases are there. This problem is going to be little lengthy. Have patience. Solution. And very, very important point. What is that important point? Whenever in the given question modulus function is there, we'll rewrite the function. We will rewrite the function. Let's see how we'll rewrite the function. Before that, you need to know definition of modulus function. Modulus of x is x when x value is greater than or equal to 0. And modulus of x is minus x when x value is less than 0. In class 11, we learned this definition, modulus function definition. Modulus of x is x whenever x is greater than or equal to 0. Modulus of x is minus x when x value is less than 0. We learned these things in class 11, modulus function definition. So, you need to know these things. First point, what I said, in these, whatever the problems I am doing today, in all the problems, this modulus function is there. Whenever modulus function is there, then we will rewrite the given function for our convenience to do the problems easier. Okay. So, here, what I'll do, given function I am writing here. Look here, I written given function. Given function. Here, you see here, this one, x is less than minus 3. X is less than or equal to minus 3. X is less than or equal to minus 3 means all x values are negative or not. You observe this one. X is less than or equal to minus 3 means all x values are negative or not. Yes, all x values are negative. When x values are negative, what do you know about modulus of x? When x value is negative, then modulus of x is what? Modulus of x is minus x. So here, what I'll do, x value less than, look here, x value less than minus 3 is there, na? So, modulus of x, I rewritten as minus x. Modulus of x will become minus x. I hope you are understanding. X less than or equal to minus 3 means all x values are negative. When x values are negative, then modulus of x will be minus x. Okay, you observe, I rewritten the given function. You observe, I rewritten the given function. In this modulus is there? No. Here as x value is negative, in place of modulus of x, I written minus x. This is what we are going to do in all the problems what I am going to do today. 7th problem, in the given function, modulus x is there. I rewritten and I removed that modulus function. That's it. Okay. Now, as usual, cases. What is case 1? I need this one, so I will bring this along with us. Okay. Okay, case 1. Case 1. Okay, what is case 1? At x equal to a. In which zone I am checking the continuity? This is case 1. I need to check the continuity of the given function when a value is less than or equal to, when a value is less than minus 3. Okay, a value is less than minus 3. Okay, good. Hero of the story. What is the hero of the story? In this first exercise, we know that if you know that previous classes, you can easily say hero of this story is limit extends to a f of x equal to f of a. Limit extends to a f of x equal to f of a, then we say that function is continuous at x equal to a. This is hero of this story. Okay, here first thing, where I am checking the continuity? I am checking the continuity in this zone. In this interval, in first case you observe all x values are less than minus 3. How many numbers are there in this zone? Infinitely many numbers are there. At each and every point we cannot check. That's why I taken x equal to a value is less than minus 3. That means, can I take this a value as minus 5? Yes, you can take minus 5 is there in this zone. Can I take a value as minus 100? Yes, you can take, because minus 100 is in this zone. Can I take a value is minus 1? No, you cannot take. Minus 1 is not in this zone. So here a value is any number which is less than minus 3. Okay, I need to check the continuity. How to check the continuity? You observe here, I'll check this one. Limit extends to a f of x equal to f of a. Then we say that function is continuous at x equal to a. So what I'll do, I'll calculate this one first. Next, I'll calculate f of a. If these two are equal, then I can say that the function is continuous at x equal to a. Okay, limit x approaches to a f of x. Okay, what I am doing, I am calculating this one first. Okay, that equal to, that equal to, 1 minute, limit x approaches to a. Here x approaches to a, which function to choose? X approaches to a value is less than minus 3. When a value is less than minus 3, we need to choose the first function. What is first function? Minus x plus 3. Okay, so what I'll do here, the function is minus x plus 3. I hope you understand this. Now I need to calculate this one, limit of this function. How we will calculate? In limits chapter, for any problem, first we try by direct method. What is direct method? In the given function, this is the given function. In the given function, wherever x is there, there you write this a value. Then what you will get? This is a minus a plus 3. So what happened? I calculated this value. I got it is minus a plus 3. Okay, right. Now, okay, I calculated this value, I got it as minus a plus 3. Now, I will calculate f of a. Okay, how to calculate f of a? To calculate f of a, first you need to know what is the function here. What is a value? What do you know about a? A value is less than minus 3, right? A value is less than minus 3 means, then we need to choose this function. Okay, so here what is f of x? F of x is minus x plus 3. When f of x is minus x plus 3, what is f of a? F of a is minus a plus 3, correct? So what is f of a? F of a is minus a plus 3. You observe, I calculated this one, I got minus a plus 3, and I calculated this one also, that is also minus a plus 3. So these two are equal now. So what I can say? I can say that these two are equal. So I'll conclude that, therefore, limit x approaches to a f of x equal to f of a. So what is the conclusion? Therefore, f of x is, f of x is continuous. F of x is continuous at x equal to a. What is a value here? A value is less than minus 3. A value is less than minus 3. So what happened? What happened? I checked the continuity in this zone. What I got? I got that it is continuous. It is continuous. That means in this zone there is no point of discontinuity. Okay. So first case is clear. I hope you understand this. Understand or not? Yes, yes, you understand this. Very good. Now we'll move to case 2. Case 2. I need this function. I'll bring along with us. Okay. I need case. I'm doing case 2. Okay. And I need this one also. I'll bring this one along with us. Okay. 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 Now I'm checking case 2. What is case 2? Case 2. What is case 2? At x equal to a, you observe here, what is case 2? I am checking the continuity at minus 3. Here single point. What is a here? A is minus 3. I am checking the continuity at one point. That one point is minus 3. Calculating this is little tricky one. I'll explain. Okay. First, what I am checking? I am checking the continuity of the function at x equal to minus 3. When we say function is continuous at x equal to minus 3, hero of this story comes limit x approaches to minus 3. F of x equal to f of minus 3. You observe this one. What is this? Hero of this story. From beginning of this chapter, we are using this very frequently. Limit extends to minus 3. F of x equal to f of minus 3. Then we say that this function is continuous at x equal to minus 3. To calculate this, what I need to do? First I will calculate this and then I will calculate this. Later I will check these two are equal or not. Okay. To calculate this, we have a problem. What is that problem? I will write here. Limit x approaches to minus 3 f of x. I need to calculate this now. Limit x approaches to minus 3. Now here x approaches to minus 3 is there now. X approaches to minus 3 means what? X approaches to minus 3 means all x values are slightly less than minus 3 or slightly greater than minus 3 but not minus 3. Here when x value, try to listen carefully, x approaches to minus 3 means x values are slightly less than minus 3 or x values are slightly greater than minus 3 but not minus 3. Here there is a chance that x value less than minus 3. Yes, we will get when x approaches to minus 3, there is a chance that x values are less than minus 3. When x values are less than minus 3, at that time I need to choose this first function. And when x values are greater than minus 3, x approaches to minus 3 means there is a chance that x values are greater than minus 3 also. I am really sorry, this comedy lovers. I am from South India. मेरा हिंदी थोड़ा खराब है. उतना अच्छा तरह मैं हिंदी नहीं बात कर सकता हूँ. Please excuse, right? So I can speak Telugu, I can speak Kannada, I can speak English and little bit of Hindi. Hindi explanation means it is a risk for me. Please excuse. Okay. X approaches to minus 3 means all x values are slightly less than minus 3 or all x values are slightly greater than minus 3. When x value is less than minus 3, in that at that time we need to choose this function. When x value is greater than minus 3, at that time we will choose this function. Okay? Yes. Comment is the 1 minute. Right. Thank you very much. Right. Okay. So here what function to choose? What function to choose now? Confusion is there. When x value less than minus 3, first function. 1 minute. When x value less than minus 3, then first function. When x value greater than minus 3, then second function. Here, what my question is, when x approaches to minus 3, which function to write? This first function or second function? Confusion is there. To avoid this confusion, calculating left hand limit, right hand limit is the best solution. So what I'll do for this problem, to calculate this one, I'll calculate left hand limit as well as right hand limit. Okay. Right. So left hand limit. How to calculate left hand limit? Limit x approaches to minus 3 f of x approaches to minus 3 from left. Look here. X approaches to minus 3 from left. X approaches to minus 3 from left means all x values are less than minus 3. It is very clear. X approaches to minus 3 from left means all x values are less than minus 3. When x values are less than minus 3, we need to choose this function. Okay, so that equal to limit x approaches to minus 3 from left, okay, minus 3 from left. Which function to choose? This first function. Write that function. What you will get? Minus x plus 3. Okay, right. So that equal to, now you observe, I need to calculate this limit. How to calculate this limit? For in limits chapter, for any problem, first we try by direct method. Okay, so here in this function, wherever x is there, there you write minus 3. Okay, right, that equal to, here first minus is there, now that minus I written. Now in place of x, what I'll write? In place of x, I'll write minus 3. Okay, minus of minus 3 plus 3, that equal to 3 plus 3, that is 6. So when I calculated left hand limit, I got minus 6. In the process of calculating this, I calculated left hand limit. Now I need to calculate right hand limit also. Okay, I'll calculate right hand limit. Limit x approaches to minus 3 from right, f of x. Okay, limit x approaches to minus 3 from right. Here x approaches to minus 3 from right means all x values are greater than minus 3. Here you observe minus 3 less than x is given na. Minus 3 less than x means, here I'll write minus 3 less than x means x is greater than minus 3 only. You all know this. Suppose 2 is less than 3, it means that 3 is greater than 2. So here as they given minus 3 is less than x, it means that x is greater than minus 3. X approaches to minus 3 from right means all x values are greater than minus 3. When x values are greater than minus 3, at the time we will choose this function. Okay, so what is the function here? The function is minus 2x. Okay, now I need to calculate this limit. To calculate this limit, we'll do by direct method. What is direct method? In the given function, this is the given function. In the given function, wherever x is there, there I'll substitute minus 3. Yes, Deepak, I'll do that shortcut videos also, but first let me complete this continuity. Okay, excuse me. In this, wherever x is there, there you write minus 3. Okay, then what you will get? Minus 2, 1 minute. Minus 2 into, what is x? In place of x, we will write minus 3. That equal to 6. You observe here, left hand limit is 6, right hand limit is also 6. Left hand limit is 6, right hand limit is 6. Left hand limit equal to right hand limit. Good. Left hand limit equal to right hand limit. So what I can say, when left hand limit is same as right hand limit, then I can say that this value is 6. Correct? You know that from the limits chapter. So I'll write limit x approaches to minus 3 f of x equal to 6. See, I calculated this value, I got 6. Now I need to calculate f of minus 3. Okay, I need to calculate f of minus 3. To calculate f of minus 3, I need f of x. I need f of x. Okay, here x value is minus 3. You look here, when x value is minus 3, here equality symbol is there. When x value is minus 3, we need to choose this function. Okay, so when x value is minus 3, f of x is what? F of x is minus x plus 3. Now what I need f of minus 3. How you will get f of minus 3? In this function, wherever x is there, there you write minus 3. Okay, so what you will get? Minus of minus 3 plus 3, that is 6. So what I got here? So I calculated, you observe this one, I calculated this, I got 6. I calculated this, I got 6. That means these two are equal. Listen here, I'll conclude. Take this to here, take this to here, keep it here. Keep it here. So what I say, limit extends to minus 3 f of x equal to f of minus 3. What I can say from this? I can say that f of x is continuous. F of x is continuous at x equal to minus 3. So what happened? 1 minute. You look here, what happened? Case 1, case 1 we checked, this is over. Case 2, I am checking the continuity at -3. What I got? F of x is continuous at x equal to -3. Actually, what is this problem? We are checking points of discontinuity. Correct? We are checking points of discontinuity. So in this zone I checked the given function is continuous everywhere, there is no point of discontinuity, and I checked continuity at this point, it is continuous in this zone also. Now case 1 case 2 is over. Now case 3, I need to check continuity of the function in this zone. When x value is in between -3 and +3, the given function is continuous or any point of discontinuity is there, that we need to check. Okay, for that I'll bring the function, we need this. Okay, case 1 is over, case 1 is over, case 2 is over, now case 3. Okay, what is case 3? At x equal to a, where a value is -3 less than a less than 3. A value is in this interval, that means here, right? So I am checking continuity of the function in this zone. Hero of the story, as usual, limit x approaches to a, f of x equal to f of a. Then we can say that the function is continuous at x equal to a. So what I'll do, first I'll calculate this one, next I'll calculate this one. If both are equal, then I can say that this function is continuous at x equal to a. Okay, so right, so first what I'll do, limit x approaches to a, f of x I'll calculate. I am calculating this one first. Okay, that equal to limit x approaches to a. Which function to choose? This x approaches to a, here a value is in this interval, that means I need to choose this function. This function is -2x. So what I'll write here? I need to write -2x. Now in the given function, wherever x is there, see here, how to calculate this direct method? Wherever x is there, there you write a, then what you will get? -2a. So I calculated this part, I got -2a. Okay, now I will calculate this f of a. Okay, calculating f of a. Okay, to calculate f of a, I need f of x. What is the function here? F of x. Here a value is what? A value is in this interval. So which function we need to choose? We need to choose -2x only. F of x is -2x. F of x is -2x. Then what is f of a? F of a is -2a. F of a is -2a. So what the point here? I calculated this one, I got -2a. I calculated this one, I got -2a. So I can say that these two are equal. Okay, so take this here. What happened? Therefore limit extends to a, f of x equal to f of a. Okay, so what I can say here, when this is true, I can say that f of x is continuous at x equal to a. Therefore f of x is continuous, f of x is continuous at x equal to a. What about a here? A value is in between -3 and +3. So I checked the continuity of the function in this zone. What I got? I got that it is continuous whenever a value is in this interval. So there is no point of discontinuity in this zone also. Case 1, I checked any point of discontinuity is there in this zone. There is no point of discontinuity, it is continuous at that point, at every point in this interval, and the function is continuous at this point also, and the function is continuous in this zone also. Okay, now I need to check the continuity of the function at this point, at 3. Okay, right. So what are the things needed? We will take. I hope you understand this case 3. You understand or not? Good. 1 minute. Little bit of settings. Add a page. Okay, we got the page. Okay, case 3 is over and I need this function. Okay, and I need this one also. Okay, right. So this case 4 is going on now. At x equal to 3, I am checking. Okay, case 4. These problems are lengthy problems, right? But easy only if you understand the concept. At x equal to a value is 3. I am checking continuity at only one point here, at x equal to 3. Okay, listen. Here, what is the hero of this story? I am checking the continuity at x equal to 3. When we say function is continuous at x equal to 3, when we say function is continuous at x equal to 3, limit x approaches to 3, f of x equal to f of 3. Limit x approaches to 3, f of x equal to f of 3, then I can say that this function is continuous at x equal to 3, right? So to check the continuity, first I'll calculate this, next I'll calculate this, later I'll check both are equal or not. If both are equal, then I can say that function is continuous at x equal to 3. Okay, so first I'll calculate this. To calculate this, we have a problem. What is the problem? Where you will get the problem? Limit x tends to 3, f of x you need to calculate. Limit x approaches to 3. Here is the problem. X approaches to 3 means what? X approaches to 3 means all x values are slightly less than 3 or slightly greater than 3 but not 3. So x approaches to 3 means there is a chance that x values are less than 3. When x values are less than 3, when x values are less than 3, x approaches to 3 means there is a chance that x values are less than 3. When x values are less than 3, at the time we will choose the second function. X approaches to 3 means all x, there is a chance that x values are slightly greater than 3. When x values are greater than 3, at that time we need to choose this function. Now you tell me what function to write. As x approaches to 3, there is a chance that x values are less than 3, there is a chance that x values are greater than 3. So confusion is there which function to choose. So best method is calculating left hand limit, right hand limit is the solution for this. Okay, I am trying to calculate this. I decided that to calculate this, we need to calculate left hand limit as well as right hand limit. Okay, I'll calculate left hand limit. What is left hand limit? Limit x approaches to x approaches to 3. Left hand limit na x approaches to 3 from left, f of x, that equal to limit x approaches to 3 from left. Here you observe x approaches to 3 from left. What it means? It means that all x values are less than 3. X approaches to 3 from left means all x values are less than 3. When x values are less than 3, which function to choose? We need to choose second function. It is very clear. So here the function is minus 2x. Now we need to calculate this one. We need to calculate this limit. How we will calculate this limit? We will calculate this limit by direct method. What is direct method? This is the given function. In the given function, wherever x is there you write 3. Okay, so that equal to minus 2 into x value is 3, that equal to minus 6. Okay, 1 minute. Okay, now I need to calculate this right hand limit also. Right hand limit. Limit x approaches to 3 from right, f of x. Okay, limit x approaches to 3 from right. X approaches to 3 from right means all x values are greater than 3. When x values are greater than 3, which function to choose? We need to choose this function 6x plus 2. Okay, so here function is clear. What is the function? X values are greater than 3 now. The function is 6x plus 2. Now I need to calculate limit of this. How to calculate limit of this? In limit chapter, for any problem, first we try by direct method. So in the direct method, in this wherever x is there you write 3. Then what you will get? 6 into 3 plus 2, that is 18 plus 2, that is 20. So when I calculate left hand limit, I got minus 6. When I got right hand limit, I got 20. Oh my god! Left hand limit not equal to right hand limit. So what I can say here? Left hand limit is not equal to right hand limit. So what is the conclusion? Therefore, limit x approaches to 3, f of x does not exist. Look here, this value I try to calculate, I came to know that it does not exist. When this does not exist, then how I'll check? When this value does not exist, how I'll check this value equal or not? This value does not exist now. When this value does not exist, then how I'll check? I cannot check. When I cannot check this condition, then I'll say that this function is discontinuous at x equal to 3. What they are asking in the question, find the points of discontinuity. We got the point of discontinuity. So therefore f of x is not continuous or discontinuous, both are same only. F of x is not continuous at x equal to 3. They are asking point of discontinuity. Now we got point of discontinuity. You see here in case 4, this is the case 4. This is the case 4. Right, thank you Mahesh. This is case 4. So in case 4, we got that point of discontinuity. So we searched in case 1, we searched in case 2, we searched in case 3. Everywhere it is continuous. I checked at 3. I got that it is discontinuous. In the question what they are asking, find all points of discontinuity. I got 1 point. Now I'll check in case 5 also. In this zone, any point of discontinuity is there not? I'll check. Okay, right. So again, what are the things are needed? We'll carry forward. Good, this is needed, and this one also needed, this one also needed. Okay, you understand case 4? Yes. That's good. Now I need to check the continuity in this zone. Okay, this is what? Case 5. What is case 5? At x equal to a value is greater than 3. I am checking the continuity of this function in this zone. Is there any point of discontinuity is there or not? I am checking. Okay, right. So what is the hero of this story? This is a limit extends to a, f of x equal to f of a. Then we say that the function is continuous at x equal to a. Okay, so what I'll do, first I'll calculate this one, next I'll calculate this one. If both are equal, then I'll say that this function is continuous at x equal to a. Okay, so right, limit x approaches to a, f of x. I'm calculating this. Here x approaches to a, 1 minute, that equal to limit x approaches to a. Here x approaches to a value is greater than 3. Then which function to choose? When a value is greater than 3, then we need to choose this function 6x plus 2. Correct? So here what is f of x? F of x is 6x plus 2. Okay. Now I need to calculate limit of this. How to calculate limit of this? In the given function, wherever x is there you write a. Direct method. So what you will get? 6a plus 2. Okay, I calculated this one. I got it as 6a plus 2. Now I'll calculate this f of a. Okay, calculate f of a. Calculate f of a. What is a value here? What is a value? A value is greater than 3. Then which function to choose? First thing here, what is f of x? Here f of a, I am trying to calculate f of a. For that I need which function to choose? Here a value is greater than minus 3. When it is greater than, sorry, a value is greater than 3. In that case I need to choose 6x plus 2. So what is f of x here? F of x is 6x plus 2. What is f of a? F of a, in this wherever x is there you write a. F of a is 6a plus 2. So what you will get here? F of a is 6a plus 2. So what happened? I calculated f of a, I got 6a plus 2. I calculated this is also 6a plus 2. So these two are equal or not? Yes, they are equal. So what I can say here, therefore limit extends to a, f of x equal to f of a. So what I'll say here, therefore f of x is continuous, f of x is continuous at x equal to a, where a value is greater than 3. So I checked the continuity in this zone. I got that it is continuous. It is continuous. So when I check in case 1, case 2, case 3, case 4, all those things, this function is given function is discontinuous at this point only. So I'll conclude. Therefore, from case 1 comma case 2 comma case 3 comma case 4 and case 5, what I from case 5, what I can say? I can say that f of x is discontinuous, where discontinuous, f of x is discontinuous at x equal to 3. Only one point of discontinuity we got. At rest remaining all points, this function is continuous. So they are asking to find points of discontinuity. I came to know that this function is discontinuous at x equal to 3. Remaining all places it is continuous. Okay, right. Yes, Max ka Jalwa. Which software has been used? I am using eCam Live software. Okay, I hope it will be useful to you. eCam Live. Okay, good. So, okay, this problem is over. We'll move to next problem. You observe this. What they are asking: find all points of discontinuity of f. Find all points of discontinuity of f where f is defined by. The function is defined like this. You observe here, again in the given function, modulus is there. We need to find where this function is discontinuous. Find the all points of discontinuity. Okay, what I will do now, first thing, what is the domain of this function? Is this function defined for all real numbers? Okay, suppose I'll check. Suppose x equal to 5. X equal to 5. Which function to choose? 5 is not equal to 0, correct? 5 is not equal to 0, then we need to choose the first function. Okay, x equal to minus 3. Minus 3 is not equal to 0. In that case, we need to choose the first function. Okay, x equal to 0. Which function to choose? When x equal to 0, we need to choose the second function. F of x is 0. So, x equal to minus 1 crore. Minus 1 crore is not equal to 0. We need to choose the first function. So, what is the domain of this function? Domain of this function is all real numbers. Okay. So, what I'll do here? All real numbers. But here, what I said in the beginning, whenever modulus function is there in the given question, we rearrange the function. Correct? So, this function varies. At x equal to 0. We know the definition of modulus function. Modulus of x is x when x is greater than or equal to 0. Modulus of x is minus x if x is less than 0. Okay, right. So here what I'll do, I'll rewrite this function. F of x equal to, here first thing is I'll suppose that x is less than, which board software, sir, and thanks for teaching. Which board software? I'm using iPad. In iPad Notability. Okay, I'm using iPad. That is in iPad also Notability app I am using. Okay, right. Here what I am trying to say, x value. What I am doing here. Okay. What I am doing here, I am rewriting the given function. Okay, as modulus function is there, as per the definition of modulus function, modulus of x is x when x is greater than or equal to 0, modulus of x is minus x when x is less than 0. So here I am rewriting this function. When x is less than 0, what is the function? X is less than 0, what is the function? Less than 0 means negative numbers. At that time we need to choose this function only. Look here, when x is less than 0, modulus of x is what? When x is less than 0, modulus of x is minus x, correct? So here, when x is less than 0, modulus of x is minus x. Okay, so what, 1 minute, little deviated. Okay, f of x is mod x divided by x. Here x is less than 0. You suppose x is less than 0. When x is less than 0, modulus of x is what? Modulus of x is minus x. Okay, so minus modulus of x is minus x. Minus x divided by x. This x will get cancelled. What you will get? This is minus 1. So here f of x is what? F of x is minus 1. Okay, so what I am trying to say, x value is less than 0. When x value is less than 0, actually we need to choose this function. Less than 0 means all negative numbers, that they are not equal to 0. We need to choose this function. When x value is less than 0, modulus of x is minus x. So in place of modulus of x, if I write minus x, this minus x, x will get cancelled. F of x is 1. I hope you understand this. So f of x is what? F of x is minus 1. F of x is minus 1 when x is less than 0. Now, okay, equal to, if x is greater than 0, if x is greater than 0, look here, if x is greater than 0, if x is greater than 0, then what happens? If x is greater than 0, right, if x is greater than 0, what is modulus of x? Modulus of x is x. So in place of modulus of x, you write x divided by x. Both will get cancelled. X divided by x is 1, right? So when x is greater than 0, when x is greater than 0, what is f of x? F of x is 1. So here you see, here x is greater than 0. What is f of x? F of x is 1. I hope you are understanding. Writing this part is important, and the function is 0 when x equal to 0. This is already given in the question. This is important part. In the given function, modulus x is there. That's why I rewritten these things to get this. Okay, right. Okay, no need of these things, we'll remove. Okay, good. So I do this problem in 3 cases. First one, this is x equal to 0 na? Case 1, I'll check the continuity in this zone. This is case 1. I'll check that in this zone any point of discontinuity is there for the given function. Okay. What is case 2? I'll check point of discontinuity at 0. Okay, I'll check point of discontinuity at 0. This is 0. I'll check here. Now case 3. What is case 3? When x value is greater than 0, when x value is greater than 0, any point of discontinuity is there in this zone, that I'll check. Okay, we'll take a small break, just a minute, water break. Okay. Right. Thank you. So see this one. This is the given function. This is the given function. I rewritten given function. I got like this. Okay. Now case 1. I'll check any point of discontinuity is there in this zone or not. That I'll check. Okay. Case 1. Case 1. Okay. Case 1. What is case 1? At x equal to a. What is a value here? A value is less than 0. I'll bring this one also. This is needed. Okay. Right. Okay. I am checking continuity in this zone. Okay. X equal to a is less than 0. What is the hero of this story? Limit x approaches to a, f of x equal to f of a. Limit x approaches to a, f of x equal to f of a. Then we say that this function is continuous at x equal to a. So what I'll do, I'll check this one first. Next, I'll check this one. Okay. Then I'll equate these two. Then I'll check these two are equal or not. Okay. limit x approaches to a f of x. Okay, limit x approaches to a f of x. Here x approaches to a. What is a value? A value is less than 0. When a value is less than 0, which function to choose? We need to choose this function, -1. Correct? So, in place of here, in place of f of x, what to write? As a is less than 0, we need to choose this one. That is -1. That is -1. Now I need to calculate this. How to calculate? By direct method. In the given function, this is the given function. In the given function, where x is there, there you write a. Here, nowhere x is there. So what you will get? You will get the same constant. What is that? -1. Okay. I calculated this one. I got -1. Okay. Now I will calculate this one, f of a. F of a I will calculate. To calculate f of a, I need f of x. F of a, in place of x, here a is there. A is less than 0. When a is less than 0, we need to choose this function. So what is the function f of x? F of x is -1. Now I need f of a. How to calculate f of a? In place of x, here a is there. In the given function where x is there, there I need to write a. But in the given function a is not there. So what is f of a? F of a is -1 only. So what you will get? F of a -1. What happened? I calculated this one, I got -1. I calculated this one, I got -1. I hope you are understanding, right? So, what I can say here, this is true. This is true. Limit extends to a, f of x equal to f of a. Therefore, limit extends to a. Therefore, limit extends to a, f of x equal to f of a, as these two are same. So what I can say from this? Therefore, f of x is continuous. F of x is continuous at x equal to a. What is a here? A is less than 0. So what happened? I checked points of any point of discontinuity is there in this zone or not. I checked. So what I got? I got that it is continuous. Whenever a is less than 0, it is continuous I got. Okay. Case 1 I checked. There is no point of discontinuity. Now I'll check this one at 0. I'll check points of discontinuity at 0. Okay. How to check? Now what are the things needed? We'll carry forward those things. I need the function. Okay. I need the function and I need this one also. We'll take these things. Okay. Good. Right. You are all ready for case 2? Good. What is case 2? What is case 2? What is case 2? We are checking the continuity at this point. Okay. At x equal to a equal to 0. I am checking the continuity at one point. At 0. When we say function is continuous at x equal to 0. When we say function is continuous at x equal to 0, we know this point. Limit x approaches to 0, f of x equal to f of 0. Then we say that this function is continuous at x equal to 0. Correct? Okay. So first I'll calculate this one. To calculate this, we have a small problem. What is that small problem? Here x approaches to 0 is there. Na? X approaches to 0 means x values are slightly less than 0 or x values are slightly greater than 0 but not 0. So what is the exact problem? I am repeatedly saying this in case if you know this point, you just fast forward this. Okay. X approaches to 0 means x value possibility there, x value is slightly less than 0, possibility is there, x value slightly greater than 0. When x value is less than 0, then we will choose this function. When x value is greater than 0, then we need to choose this function. So here what I am trying to say, limit x approaches to 0, which function to write here? What function to write? X approaches to 0 means there is a chance that x values are less than 0. When x values are less than 0, f of x is -1. X approaches to 0 means there is a chance that x values are greater than 0. When x values are greater than 0, f of x is 1. So here there is a chance of both the functions. So what is the best method? I am confused here. Which function to choose? Both functions are qualified to write here, but we cannot write both the functions. So to avoid this confusion, best thing is calculate left hand limit and right hand limit. Okay. Right. delete. Okay, left hand limit, okay, limit x approaches to 0 from left f of x. Left hand limit we are calculating, that's why x approaches to 0 from left. X approaches to 0 from left, it means what? X approaches to 0 from left means all x values are less than 0. All x values are, oh god, all x values are less than 0. X approaches to 0 from left means all x values are less than 0. When x values are less than 0, what is the function? Function is -1. So here the function is -1. Now I need to calculate limit of this. How to calculate? In the given function where x is there I need to write 0. But actually here 0, x is not there. So what you will get? You will get it as -1. So I calculated left hand limit, I got -1. Now I will calculate right hand limit. How to calculate right hand limit? Limit x approaches to 0 from right f of x. Okay. Limit x approaches to 0 from right. 0 from right. X approaches to 0 from right means all x values are greater than 0. When x values are greater than 0, what is the function? Function is 1. Okay. F of x is 1. Now I need to calculate this. How to calculate this? In wherever the function is there, in the given function wherever x is there you write 0. But in the given function x is not there. So what you will get here? This is 1 only. So you look here, left hand limit is -1, right hand limit is 1. Oh my god, what happened? Left hand limit is not equal to right hand limit. These two are not equal. So limit exists or does not exist? Limit does not exist. So I'll write here, left hand limit is not equal to right hand limit. So what is the conclusion? Therefore limit x approaches to 0 f of x. What about this one? This limit does not exist. Limit of the function does not exist. So actually I am trying to calculate this. I got that this does not exist. When this does not exist, how I will check these two are equal or not? This value does not exist. Na? I cannot check that this is equal to this or not. I cannot check. So I say that this function is discontinuous at x equal to 0. I will conclude. Therefore, f of x is discontinuous. Discontinuous at x equal to 0. I checked the continuity in this zone. There is no point of discontinuity. I checked the continuity at this point and I came to know that it is discontinuous. Okay, just a minute. Okay, so in this case, no point of discontinuity. At this point, discontinuity is there. It is discontinuous at x equal to 0. Now I need to check in this zone any point of discontinuity is there or not. Okay, for that I need this function. We will carry forward this one. I need this function and we will take this also along with us. Okay, right. What I am doing, what I am checking here, case 3. Okay. Oh, it's almost 1 hour. Okay, no problem. Case 3. What is case 3? At x equal to a value is greater than 0. I am checking the continuity of the function in this zone. Okay, so for that, hero of this story, as usual, limit x approaches to a f of x equal to f of a. Then we say that this function is continuous at x equal to a. So what I'll do, first I'll calculate this one. Okay, next I'll calculate this one. Later I'll check both are equal or not. Okay, limit x approaches to a f of x. I am calculating this, that equal to limit x approaches to a. What is f of x? What is f of x? X approaches to a. Here a is greater than 0. When a is greater than 0, which function to choose? We need to choose this function. So here what I will write, in place of f of x, I need to write 1. Okay. Now I need to calculate this. How to calculate this? In this, wherever x is there you write a. Okay. So what you will get? This is 1. Okay. So I calculated this one. I got 1. Now I will calculate f of a. Okay. F of a. F of a. To calculate f of a, I need f of x. Here, to which function to choose? To calculate f of a, I need which function to choose. Here a value is there, na? A value is greater than 0. When a value is greater than 0, what is the function? Function is 1. So here f of x is 1. Now what I need? I need f of a. I need f of a. Here in place of x, here a is there. So in the given function, here in this given function, wherever x is there, there you write a. But here there is no x. So what it will be? It will be 1 only. So f of a is what? F of a is 1. So I calculated this one, I got 1, and I calculated this one, I got 1. So what I can say here? What I got? I got limit extends to a. I got that, therefore limit extends to a, f of x equal to f of a. This value is 1, this value is also 1. So I can say that limit extends to a, f of x equal to f of a. So what is the conclusion? Therefore f of x is continuous. F of x is continuous at x equal to a whenever a is greater than 0. So I checked the continuity in this zone also. I got that it is continuous. It is continuous. So case 1 is what? Case 1 in this zone it is continuous. Case 2 it is discontinuous. Look here, we got it is discontinuous. Case 3 what I got? In case 3 I got that it is continuous. So in this I'm checking continuity in 3 cases now. So I got that at this point this function is discontinuous. I'll conclude this. Therefore from case 1 comma case 2 and case 3, what I can say? We can say that f of x is what they are asking in the question. Find all points of discontinuity. Appreciated Ramalingam. Yes, thank you very much Ramalingam Putta. Thank you. F of x is discontinuous. F of x is discontinuous at x equal to, f of x is discontinuous at x equal to 0. They are asking to find points of discontinuity. I got that this function is discontinuous at x equal to 0. I hope you understand this, right? Now one more problem is there. One more problem is there. This is smaller problem only. You observe, find all points of discontinuity of the function. Find all points of discontinuity of the function, and the function is defined like this. F of x is x divided by mod x and x is less than 0. F of x is minus 1 when x is greater than or equal to 0. This function is given like this. You observe, in the given function modulus function is there. Today what are the problems we are doing? In all the problems in the given function mod x is there, right? Okay, first thing, to find all points of discontinuity of the given function, we need to know what is the domain of this function. What is the domain of this function? Is this function is defined for all real numbers? For examples, x equal to 100 is there. Which function to choose? 100 is greater than 0. Obviously, we will choose second function. Okay, x equal to 0 is there. When x equal to 0, you see here equality symbol is there. When x equal to 0, then we choose second function. Suppose x equal to minus 2 is there. Then which function to choose? Minus 2 is less than 0. We will choose the first function. So what I am trying to say, this function is defined for all real numbers. So domain of this function is what? Domain of this function is all real numbers. So here domain of this function is all real numbers. All real numbers. So what the point is, I need to check continuity of this function on all real numbers. Here the point is, I'll start the solution. Here the point is, in the given function modulus is there na? When modulus is there, then we'll rewrite the function to make the things easier. Okay, so modulus function definition is what? Here no need of this. Modulus function definition is what? Modulus of x is x if x is greater than or equal to 0. Modulus of x is minus x if x is less than 0. Right? So here I'll rewrite the function. How to rewrite the function? F of x equal to, here what they given? X divided by mod x is there if x is less than 0. Here you see here x divided by mod x is there na? X divided by mod x is there na? X less than 0. When x is less than 0, what is mod x? mod x is minus x. So what I'll write here, this is x divided by what is mod x? X is less than 0 na, mod x is minus x. So I'll write here minus x. So these two will get cancelled. What you will get? You will get minus 1. Listen this carefully. So x is less than 0. This is the given function. This is nothing but minus 1. I hope you understand. So what I can say here, this observe here, I am just striking off this. I got it is minus 1. When x is less than 0, mod x is minus x. X divided by minus x is minus 1. I got like this. And this information is already there. That I will write is minus 1 if x is greater than or equal to 0. You observe there is no variation in the function. F of x is minus 1 when x is less than 0. F of x is minus 1 when x is greater than or equal to 0. I hope you are understanding what I am trying to say. When x equal to minus 100, then what is the function now? Minus 100 is less than 0, function is minus 1. When x equal to 100, then what is the function? When x equal to 100, 100 is greater than 0, function is minus 1. So here, this is also, 1 minute, this is also minus 1, this is also minus 1. So no need to write separately like this. So what I'll do, I'll rewrite this function f of x equal to minus 1 when x is a real number. This is the main part. I rearranged this function, I got like this. I hope you are understanding. I rearranged this function, I got like this. Okay. Now there is no question of doing case 1, case 2 here. So okay, only one case will come. What is that case 1? At no need of this, no many cases now. So I'll write like this: at x equal to a is a real number. So only one case will come. Okay, right. One case will come. This is the function. So first thing, what is the hero of this story? Limit x approaches to a, f of x equal to f of a. Limit x approaches to a, f of x equal to f of a, then I say that this function is continuous at x equal to a. So what I'll do, first I'll calculate this one. Okay, next I'll calculate this one. If both are equal, then I can say that this function is continuous at x equal to a. Okay, first calculate this one, right? Calculate this one. Okay, equal to limit x approaches to a. X approaches to a. What is a here? A is a real number. When a is a real number, what is the function? The function is minus 1. So you write here minus 1, that equal to. Now in this function, wherever, now we need to calculate this. To calculate this, in the given function, wherever x is there, there will write a value. In the given function, there is no x. So what is the answer? The answer is minus 1. Now I need to calculate f of a. Okay, I need to calculate f of a. Okay, I'll calculate this f of a. F of a. To calculate f of a, we need the function. Here only one function is there, that is minus 1. Whenever, what is a? A is a real number. When a is a real number, what is the function? The function is minus 1. So what you will get, this is minus 1. So what you got here? Therefore limit x approaches to a, f of x equal to f of a. When I got this statement, I can say that this function is continuous at x equal to a. What is a here? A is a real number. So I'll conclude. Therefore f of x is continuous at x equal to a. What is a? A is any real number. So what they are asking actually in the question, find all points of discontinuity. And here this function is only that minus 1 for all real numbers. So when I checked at all real numbers, I got that this function is continuous at all real numbers. That means there is no point of discontinuity. So what you will write, therefore there is no point of discontinuity. There is no point of discontinuity. I hope you understand this. Understand or not? Good. So whatever the 3 problems I did today, in all the 3 problems in all the three problems, mod x is there. That is important thing. See here, this is the first question we did. In this, here mod x is there. So I rearranged the function and I checked the continuity on its domain. And you see this next question. Next question. You see here, in this function also, mod x is there. I rearranged the function and I checked the points of discontinuity. Next, see this one. This question, in the given function mod x is there, I rearranged the function and I checked the continuity and checked the point of discontinuity. In next class, finding the value of k when the given function is continuous, finding the values of a and b, that type of problems are there. That type of problems, total 7 problems are there. In next class, we will do those problems, right? These are little confusing, but not confusing actually. If you are good in concept, you can do these problems very easily. If you are good in concept, you can do these problems very easily. Only the thing is, these problems take some time, right? I hope you understand this class. If you like this video, please drop a like for this video and share this video with your friends. And if possible, to support our channel, please join as a member so that I'll add you in my WhatsApp group, right? Thanks for watching. Take care. Bye bye.